Okay, now we're going to talk about law of cosines. And this is a little bit easier-ish. They don't have the ambiguous cases. However, the formulas are a hot mess, so they're a little bit more in-depth to remember, okay? So when you're solving triangles, when they're a right triangle, SOHCAHTOA. We got all that. When it's side, 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 or side, angle, side, you're going to use law of cosines. Anything else that you're given, you got to use law of sines, okay? So, side, angle, side, or side, side, side. Here are your three formulas. Pause it. Write them all down. So, side squared equals side, the opposite, minus 2 of the opposite. So, it's like these two are the same. C and gamma, right? B and beta. A and alpha. Everything else is the other two letters. So it doesn't really matter if it's B squared and A squared and BA. Like, it's all the same, right? So kind of keep that in mind. Your outsides are the same, right? Side and the angle, side and the angle. And then everything else. So you really have to memorize the formula one time. Okay? Now, when you flip this over, we do have the angle solved for, but that's a lot of extra formulas to think about. If you just memorize these, then you can always solve for that, right? So, like, if I wanted to solve for this one, gamma, right? I would say C squared minus A squared minus B squared equals negative 2AB cosine. Can you see that? I'm sorry. Gamma. And then I would divide by that. So, C squared minus A squared minus B squared divided by negative 2AB equals cosine gamma. And now on our other formula chart, the negative's taken out. So technically what it has is negative C squared plus A squared plus B squared over positive 2AB. Either one, to me, I'm good with. Because you either divided the negative out or you didn't. It doesn't matter. You're still going to get your right answer, okay? Either way, memorizing these three and really memorizing the outsides are going to be much better for you, okay? All right. So let's solve this beautiful triangle. Y'all know I like me a picture. 2, 3. So that must make this 60. Side, angle, side. Ta-da! Right, and so this is going to be alpha, this is going to be beta, and this is going to be C. Just so we're kind of clear on where we're at. So first thing I like to do is get that C out of the way, because that one's what the formula is already bred for, right? C squared equals A squared, so that's 2 squared plus 3 squared minus 2 times, does it matter if I did A and B or B and A? No, it does not. Cosine of 60, because we got that, right? So now this is a literal plug and chug. I would do all this nonsense and then subtract it, okay? So, let's turn on our calculator. 2 times 3 times 2 times the cosine of 60. Well, that was nice. So, I've got 4 plus 9 minus 6. So, C squared is equal to 7. So, C is equal to the square root of 7, which is 2.65. Now you can leave that here, 2.65, right? Or you can do all the other stuff. Now, when I was working this worksheet, and I was like, well, now that I got this, even if I leave this as square root of 7, whatever, I can do law of sines, right? I got a ratio. Oh, man, that's going to be so much easier. And it is ish. Here's what's going to happen. You're not going to pay attention, and it's going to say side, side, angle. It's going to be one of them donkey ones, right? Remember? The boot cheek ones. Side, side, angle. Spell that backwards, right? And you're going to have an ambiguous case. So when you are dealing with law of cosines, you got to deal with law of cosines. Okay? Leave it as that. Do not switch it up. Okay, we know how to solve and do all this jazz, and I'm going to need another piece of paper because this is going to get messy here, but we got it. Okay, so now I have this, I have C, I have this too. I need to find this. So I'm going to plug it in to the B squared one, right? So b squared is what? Equals c squared, which is square root of 7, like we know that, plus I'm lost and I'm tired, and 2 squared minus 2 times square root of 7 times 2, and cosine of, what are we solving for? Beta. Okay, so I got to do this and move that over. So I have to subtract this, subtract that. Okay, so that's what I'm going to do first. So I have 9 minus, and you're going to do parentheses. Well, square root of 7 is 7. Come on, right? Can we all agree on that? So I've got 9 minus 7 minus 4. So all I've done is move these two over. So I have negative 2 equals negative 2 times the square root of 7 times 2 times the cosine of b. So I'm going to just divide all this out. So negative 2 divided by, I'm going to put it in parentheses. Negative 2 times the square root of 7 times 2. Close your parentheses. Okay, so now I have the cosine of beta equals some crazy mumbo jumbo number, right? And I've got to do that inverse of the crazy mumbo jumbo number equals beta. So now what I'm going to do is trig, inverse, control, answer to recall it. So beta, 79.12 degrees. Okay? I'm going to do the same thing for alpha. Remember, we can't really use this because it's rounded and all that jazz, right? We got to go the long way and it sucks. And I'm sorry. So now we're going to practice again, and we're going to say, hey, this is a squared because we're solving for alpha now, and I got square root of 7 squared plus 3 squared, so it's going to be 9, right? We're going to minus 7, we're going to minus 9. Minus 2 times square root of 7 times 3 times the cosine of alpha now, because that's what we're solving for. All right, so I've got 4 minus the 7 minus the 9. All I did was move these two over. So I got negative 12 equals negative 2 times the square root of 7 times 3 times the cosine of alpha. So negative 12 divided by, and then parentheses, and I can chunk this whole thing in my parentheses. This calculator is really smart, okay? Negative 2 times the square root of 7 times 3, close the parentheses. So now I've got the cosine of alpha equals crazy mumbo jumbo number. And I'm going to then do the cosine negative 1 of mumbo jumbo number equals, so you got to recall that answer, control negative 40.89. So do you see how we would have ended up with a little bit of a difference? Just a little bit, but we'd have ended up with a little bit of a difference here. In fact, when we add all this up, I bet that does it give me over 180? Just a little bit. Yeah. So you see how we can't use those rounded numbers? Because technically my rounded numbers are not quite right. I'm a little bit over what a real triangle is, but that's okay. All right. Whew, that was a lot of work. How many problems we got in that? Wow. So many problems. Whoa. Boy, I said I needed more, but I don't know if we need more. Let's do this one because I was given side, side, side now. Okay? So, if I'm going to make this 4, that means this is alpha. If I'm going to make this 3, that's going to be beta. If I'm going to make this 6, that's going to be your gamma. Okay? So now that I have side, 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 I'm going to have to use the funky formulas, but that's okay. Okay? I'm going to get another sheet of paper again because I did not give myself enough space here. Like, totally not enough. All right. So with this, side, 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 I'm going to have to say, I don't care which one you want to go with. So let's say we do alpha first, right? So 4 squared equals, and then it's just the other two sides. So 3 squared plus 6 squared. It doesn't matter which one, right? It's okay. Minus 2 times 3 times 6 times the cosine of alpha, because that's what we're looking for. And then I got to move this over again. So remember, we're going to subtract 9, subtract 36. Because I want to get all this over here, so I'm left with just that. So what does that give me? I don't know. 16 minus 9 minus 36. So I have negative 29 equals negative 2 times 3 times 6 times the cosine of alpha. So I'm going to divide by this ugly mumbo jumbo. And this is actually not bad. What is 2 times 3 times 6? 36. So negative 29 divided by negative 36. And it gives you a fraction, and who cares? Cosine of alpha equals 29 over 36. And again, I have to do my inverse. So trig cosine. And then I'm just going to control answer because I don't care about that. So my first angle is 36.34. And then I'm going to rinse and repeat and do the same thing again for the other two. So now let's solve for beta. So 3 squared equals 4 squared. Like, do you see how this has the same pattern? It's just if you remember the ends, it's all the middle. Rinse and repeat. What are we doing? Minus 2 times 4 times 6 times the cosine of beta this time. So I've got 9 minus 16 minus 36. So negative 43 equals, what's 2 times 4 times 6? Negative 48 cosine of beta this time. So I'm going to have cosine of beta equals 43 over 48. Because you divide that. Right? I just know that, that's not going to be nice and pretty. It's going to be ugly fractions. And then I'm going to end up doing the inverse. So beta is going to equal trig cosine inverse 26.38. And then I've got one more because I need to find gamma now. So we're going to start with the 6. So 6 squared equals 4 squared plus 3 squared minus 2 times the other two signs. Cosine of, I always do the y, I'm so sorry. Okay, so again, I'm moving these over. 36 minus 16 minus 9. So I got 11 equals, and then I'm just going to multiply that. 2 times 4 times 3, so 24. Okay. All right, and so then I'm going to have cosine of gamma equals 11 over negative 24. And then I have to do that inverse again. So we're going to do the inverse trig function here. Negative 11 divided by 24. And my gamma is equal to 117.28. And I bet if we add all these up, so 117.28 plus 26.38 plus 36.34, bam, boy, that was nice. Look at that. That's a mic drop right there. Okay? And that's really it. It's just a plug and a chug. Now, in class, we did a few more examples, but, that's it. So you're either going to have a couple of informations and you can use just the regular one, or you're going to have to do this process over and over and over again.